Okay, hey guys. I've been working on this PID controller for, I don't know, on display for the last week, and I don't know, stitching everything together. So I've got a scale here. This is the controller. It's plugged in the back, 12 volts, and I've put an ESP board in there that's hooked into the RS232 and getting the weight reading every time it updates. And then I've got this lead fluid pump here. It's actually a periscopic pump, can't say the word, but it's had its head changed to add a screw feeder. And this is just the bottom, sand. It was a mixture of plain sand and fezzy for different weights, so that you could see that, like, to keep the same feed rate, since that's the plain sand, it's all mixed in now, but yeah, to keep the same feed rate, when it went from white sand to black sand, it probably weighs like 3 times more. You have to slow the screw feeder right down to keep the same weight loss, which is a good test of a PID controller. So this is my input, and this is my output, pump speed being the output. And then I have this display. It's very cool. ESP32 S3 touch by Waveshare, and then all the magic is happening on this chip. You can even have like Modbus or something over the RS485 or CAN bus and plug in more sensors and stuff. But I've been very impressed with how much it can do. So start from the start, let's restart it. So this is my display at the moment. Planning on changing it. The set point is like the target, like weight loss. So it's in grams per minute at the moment. You've got your incoming, which is what the scale's weighing. A bit of movement and it will give a little bit of a wrong value. The output's the pump speed, and then the error is literally the set point minus the input. So I've got all the settings here. Okay. So the mode, you can see that. That. You hear that beeping, so when you go from off to one of these modes, it's turning the pump on and then setting the speed, if there is a speed. The PID tunings there, very low for this, and then some of the other settings, like alarm limits. So right now, if I go into auto mode, we want that input to hit that set point automatically though, so it doesn't know what the output is yet, so it's got to go find the perfect output to match that. So we can see it started moving, and the pump motor is creeping up, and then I've got weight loss here. So this has internal logic calculating the weight loss, and it's just passing it through as an input over MQTT. So you can see it's 80. It should keep going up while it's not over that set point. Until it hits, and now it's overshot. So it should start going down. I don't know if this is the best kind of use case for a PID, but it certainly works for it. So I've got some other screens too that I've made. So the alarm say output low. It's because the hysteresis is at 10, so it needs to go to 30 and it's only sitting at 24. So if we pump this set point up, should change. We can get the output over. Nice. So that stops alarming. Got this settings menu, which is all the settings that map back to the PID. I'm having a lot of trouble with this persistence, getting it to save through a reboot. It sometimes works, sometimes doesn't. And this is just an overview of those settings, like a quick view. Got the Wi-Fi connection page. You can see MAC address, IP, etc. Debug. It's just so I can see what's going on. So this is on some of the callback functions. So every time one of these values changes, it should call a callback and then populate this. Every time I change a config or persistence is triggered, it will also do that. And maybe my favorite is this graph. I just changed the size so you can't even see the bottom axis, which is sad. But yeah, super cool. And it's a shame you can't see the time. If we go zoom out, you can see that that's the set point. Zoom out a bit more. You can show the alarm lines. I have to zoom out more. Yeah, so yeah, that's the PID sitting around at set point. And now change it to something like 250. And go look at the graph again. You can see it's going way out of whack. So you can see the set point just changed. And we should see it hit an alarm line once it ramps up. You can see the values changing. Pumping up. Try and hit that faster rate. That, you see that little dip's probably me touching the scale. And you can see it's above that alarm, high alarm now, and then it's gone up and reached that set point. If we come back here, you see it's flashing. Input high alarm. Other cool modes is manual mode, or I'll show you hold first because it's actually going. So it's sitting around 77, but it's changing every time it gets feedback from the input. If I press hold, that's cool. So then if I go and like touch the scale and the input goes haywire, like you want to top it up or something while it's running, you don't want the PID to be triggering because it's getting a input of 3,000, it's 5,000 grams per minute now. You don't want it to be making calculations based on that information, so you can wait for it to level out again. And it's just holding the outputs nice and stable. Yeah, you can see If I auto scale that, it's going to go crazy. You can see it shot right up there to the maximum and minimums. It's clipped it because I've scaled it. And now it's leveled out again at 250, which is actually the set point anyway, so it's very smooth. The stuff doesn't need a PID controller while the sand is consistent. And you can go to manual mode, which will go to whatever you set there, so straight to 50. There. Yeah, if you go back into auto and it would ramp back up to 250. Off, that's triggering a callback, so it's turning the pump off. If I go into any one of these modes, it turns it on and then sends that output. Yeah, so direction, off output's the output that it will go to when you go off. I want it to go to 0, manual is what I just showed you. Tuning, that's the PID settings. So sampling on event, so I've got it tied to an input sensor. Every time that input sensor gets a new reading, it will do a calculation, but you can put it in time mode, which will trigger every 500 milliseconds. Let's forget auto. You can see it moving a lot quicker, which is not very good for this use case because it's only getting a reading every 2 seconds. So it's calculating on no information, so I haven't found that useful for this particular use case. Limits. I haven't done any testing on these yet. The scaling, so I've normalized everything, so it has to be within a range because the sensor could technically be any value. So this is just giving that value a high and a low point, so like 0 to 100%, and that's what you can see something on that graph. If we can zoom back out again. So that reached the 0% point, that reached the 100% point, even though the raw input was 5,000 or something, and that was negative. It's capped it at 0 and 2,000. So I have to set those parameters. Yeah. I think that is about it. So actually it was very confusing wrapping my head around the raw normalize and display thing, and I'm still not sure I'm happy with how I've implemented it. I'll keep tweaking it. I love the graph. I'm very impressed with what this display can do, especially for how much it costs. It's like 70 Australian dollars or something. So super cheap, and it's capable of a lot. Thought I'd try and share. If anyone's got any ideas, that would be cool. It's still kind of mid-project, but I think it's getting close to being useful now. So. Yeah. So I don't normally make videos, so I apologize for my very, very shoddy camera work and my potato phone that focuses sometimes. Alright, cheers. I just wanted to show this graph because it's probably my favorite thing. So I've got the 0 point and then the minus time. If I go zoom out on the x-axis, you can see it adjusts, and yeah, it's a bit better when you can actually see the scale. So what have I got it set at? 250. So it's slowly creeping up. My P value is very low, so the changes are slow. Very slow. Another cool way to get it up there quickly is to set this manual mode to 250. Oh, that's going to go too fast. Anyway, let's watch it overshoot. That just really sent it off. And now I'm going to go back into auto. So it should have to ramp right down to my auto scale. That. It's me setting 250 for my motor. Oh, 10, 100. So that's kind of a cool way to speed things up. Another thing I didn't show, it's not on the display, but your terms, so they're like the past calculations in the PID logic that it uses to calculate its next reading. You can see them changing. But yeah, I very much like this graph, and you can also put the error line, the output, which doesn't really make sense on this scale because that's the input there and that's time. It's there anyway. That's the 0 line. You can turn the alarm lines off, so clearly this is very much an alarm at the moment. Which you can see, yeah, you can put high active. So yeah, cool. Just wanted to show you that.